Okay, so if you go to that number 11, the blank space, again, we're working right here in the blank space on your formulas you need to know but aren't on the reference sheet. On number 11, here we go. We can call it conditional probability. All right, conditional probability in number 11. Here it is, ready. Probability of A. I'm going to ask you guys what that little symbol means. B. Anybody remember what that one meant right there? A what B? Given B, yep. A given B. It's a fraction. Anybody remember what it's equal to? What goes in the numerator, what goes in the denominator? Okay, ready? In the numerator, A. What's that symbol I just put up there? This one right here. And. That they both happen at the same time goes in the numerator. Both happen at the same time. Anybody remember what we put down on the bottom? Whatever's given. In this case, what's given? B. This could be a probability. This could be the number of times, right? But A and B always go on top. B, how many times it happens, goes on the bottom. All right? Questions? Keep that sheet right near you because the next one we do, I'm going to have you write in something as well. All right, so we already did 26. Okay, let's go to 30 now. 30. Here we go, 30. Read through it real quickly and then we'll talk about it. Don't get rate of growth confused with rate of change. They're not the same. Okay, do not get them confused. Exponentially. There's an equation that you probably used last year that dealt with rate of growth with an exponential equation. Number 12 right now. Number 12. Ready? Number 12 on your sheet. Here it is. Here's the equation. Exponential equation. Here it is. Exponential equation. Ready to go? Y equals. Anybody remember it? A times B to the X. A times B to the X. Ready? Anybody remember what A represented? Call it out if you do. Anybody remember what A was? That's my original amount. All right, there's my original amount. B, that's my rate of growth, which is what we're looking for here. And X, anybody? Time. All right. Ready to go. Let's go back to the problem. You help me fill in each piece right now. Because which one, if I'm looking for algebraically determine the rate of growth, which variable am I going to solve for here? B. So we should be plugging, ready? You should be able to help me plug in for Y, A, and X right now. B should be all by itself because that's the rate of the growth. All right, let's go. Original amount, anybody, original. In 1966, the minimum wage was $1.25. Original amount, $1.25. Times B. Ooh, what's my time here now? Well, what year did I start? 66, and I went to 2015. I got some people using the calculators. Go, yep. What's my time period here? How many years? 49 years, yep. still got to put something over here, which was, what was the amount after 49 years? $8.75. All right, we're ready to go now. Got everything plugged in where I need. Help now, help, help. Get B by itself. We've done a couple of these already. What have we always done first? Divide by the number out in front. So divide both sides by $1.25. Yep. Go ahead, go. Sarah, what do you got? What's that? Yep, 1 second. What do we end up getting here? 7. On the right side, B to the 49th. Now, last couple times we've done something that looks similar to this. We've done logs, right? We've done logs, but that's when the variable is in the exponent. We could do logs. Not a good choice here. When the variable is the base. Anybody remember last year if the variable is the base? No logs involved. Good news, no logs involved. Sarah? Well, it's like the square root, but this isn't squared. This is to the 49th. So I'm really taking the 49th root. Or I don't think you guys did it that way though last year. I'm thinking that to get rid of the exponent, you raise both sides to the reciprocal of that. Sound familiar a little bit? 49 over 1, flip it. What do you have? 1 over 49. So if you want to get rid of that exponent, that's not a variable, you raise it to its reciprocal. I think that's the way you guys probably did it last year. Yeah, it is, yes. Yes. I think the only reason I'm showing you this, Jess, this way is because it's easier for you to perform in your calculator versus taking the 49th root in your calculator. Okay? All right, go to your calculator. 7 raised to the 149th. I don't need to show you how to do that one. And here you go. You and I are both getting what? 1.040511534. Everyone matching up? We all good? So again, just a little review. We're not done yet. We're not done. Little review. If that's an x, your exponent is the variable, then you take a log. Okay, but if it's a number, you raise both sides to the reciprocal. Okay, so my answer should be 1.0405 da da da. No, that's not the rate of growth. Here's why, and I didn't go over this on purpose. Your rate of growth, that number, what we just saw for B, 1 plus the rate, if it's growth, or it's 1 minus the rate, if it's decay problem. Is this problem growth or decay? Growth. So that number you just found, look at that number you just found from your calculator. That's actually 1 plus whatever the rate was. That's what that number represents, 1 plus whatever the rate was. So how can I find my actual rate now? Subtract 1 from it. Yep, go ahead, subtract 1 from it. Go ahead, everybody, subtract 1. You probably still have it in your calculator. And it says to the nearest percent. So what do you have to do with that decimal right now you're staring at? Multiply by 100, everyone? Yep, multiply by 100. So the rate is actually what to the nearest percent? 4%. Again, the B value is going to be 1 plus the rate if it's a growth problem, or that number is going to be 1 minus the rate if it's a decay problem. Okay? So that will not give you the rate. Everyone see a little difference here. You good here, Matt? Everyone else all right? Questions? Go ahead, Austin. Okay, because, ready? This right here is 1, because it's a growth problem. First of all, this is a growth problem. It says find the growth, right? So this B value that we just found, that's adding the rate plus 1. So if I wanted to find what the rate was, so 1 plus what gave us this number? And it was if I just take the 1 off, 0.0405. And if I multiply that by 100, that's where I get my 4%. Okay? Other questions? All right, let's go then. So you have time to do some on your own. Going to 31. 31. Everyone got another block open? What are we on? Number 13? Number 13, formulas you need to know. Here you go, number 13. If a function's odd or even. If a function's odd or even. Everyone ready? If a function is odd. If a function is odd, f of negative x equals negative. I'll explain what all this means in a second. F of negative x equals negative f of x. If it's even, f of negative x equals f of x. Just copy that down for a second, and I'll tell you what it means. Here's what this means. When you plug in negative x to the function, which we'll do here in a second, when we plug in negative x, if I get the original one back, it's even. If I get the original one back, but all the signs are changed, that's what that means right there, guys. Right here, that all the signs are changed on the original, it means it's odd. And if neither of these happen, it's neither even or odd. So what you need to do to test first if it's even or odd, take x everywhere you see an x, and we're going to plug in negative x. And then compare it to what the original was. All right, so go back to the problem right now. Go back to the problem. We're not dealing with f, we're dealing with... What are we dealing with? Not dealing with f, dealing with j. Okay, so what we need to do to test if it's even or odd, we need to plug in negative x now. Everywhere I see an x in this function, I'm going to plug in a negative x. So instead of x to the fourth, it'll be, in parentheses, negative x all raised to the fourth. Minus 3 times negative x squared minus 4. Let's see what happens now when I do the algebra. Here we go. Need somebody's help. Now we're going to go back to the good old numbers here. Let's do this. 4. Anybody 4? Okay, here we go. Austin, ready? Negative x to the 4. I'm raising it to an even. So what's this going to become now? Just x to the 4th. Positive, right? Because I'm raising it to an even number. Positive x to the 4th. Everyone all right on where we got that? Yes. Okay, ready? What's negative x times negative x? X squared times another negative x. So we got x squared times negative x. Well, here you go. Ready? Negative x times negative x times negative x times negative x. 4 negatives multiplied will give you a what? Positive x. The bottom, negative times a negative, positive. Negative times a negative, a positive. 2 positives multiplied together give you another positive. Good? Okay, so that's where I'm getting it from. Austin, back to you. Negative x all squared will give me x to the 2nd times that negative 3 is still going to be minus minus 3x squared, and then not doing anything with the 4. There we go. What did I end up with? The original, right? I ended up with j of x. So by plugging in negative x, if I end up with the original, what's that tell me? Odd or even? This is an even function. Okay, if I end up, after I plug in negative x and do the algebra, that's what Austin did for me. If I end up with the original, that tells me it's even. If it was odd, if it was odd, negative, positive, positive, I'd end up with opposite signs. That's what that means up there, that you end up with opposite signs of the original. Okay? Then I say it's neither, right? Because what are the choices? Even, odd, or neither? Like if I said I got something that's not the same or the opposite of the original, I just say it's neither. Okay? Yes, Jess?
Basically, if all exponents are either even or zero, then it's even. If they're odd, then they're odd.
But if there's one of each, it would be neither. Okay? Good? Other questions? Okay, we're good there. I think this might be, yes, it is. We're done. We're done. Put the August 2017 one away. Done with that. Yes, there are questions we didn't answer, but up on Aspen are all the answer keys. So we're going to June 2017 now. Well, it was a decision by myself, Mrs. Lynch, and Mrs. Wise, who teach this course, and the decision was based on we've been doing this for a while, and the motivation. You need what? Regents review in 3 weeks. Yeah. The motivation's not there in June because this test is given a week before graduation. Everybody is in school. If you decide to go to school next year, everyone's in, picking classes already, so there really wasn't much motivation here. And now there's a little bit more since it's just January, so that's why. And we'll see how it goes, if it was a good decision or not. 13, June 2017, number 13. Go ahead, let's read through this. We've done a couple of these problems before. So which equation out of the 4 produces the same results as the one I'm given here? But it's a little bit different. First thing is, whoa, this wraps in perfectly to that exponential problem we did before. Remember, Austin was like, well, how do I know add and subtract 1? Well, take a look at here. Is this a growth or a decay problem here? This is definitely decay. So remember, this isn't my rate of growth. That's 1 minus my rate of growth, right? What's the rate of growth here? It comes out and tell you. What's the decay rate here? 25%. Do you guys see why there's 75 in here and not 25? Because this number is 1 minus the rate. You see that? So that wraps in perfectly there. All right. You will not, this right here, that B value is not your growth or decay rate. It's 1 minus if it's decay, 1 plus if it's growth. All right. So which one of these 4 matches that one? So if you remember, what do we have? Question? So 1 minus 0.25 gave me that 0.75 because it's decaying. Yes, so that's why I did minus. Okay, or decay decreasing. Okay. So which one of the Which one of these four choices is going to give me the same results as this one right here? All right, so what we've done in the past is we've said, hey, all right, 714.075, and we started plugging in 1, 2, 3, everyone remember? And then we found out a couple answers, and we started plugging the same numbers in to my multiple choice and figured out which ones were all equal. But there's a catch here. Why is there a catch? What's that right there? I know that's a D, but what's it represent? Decades. And what's this here? That's a Y, which it would be what? Years. So when you plug in 1 here, that's not the same as plugging in 1 here. That's 1 decade, that's 1 year. Anybody know how many years in a decade? 10. Okay? 10 years in a decade. Yep. So if I want to check 1 year, what do I have to put in for D then? Think about this. I can't plug in 1. Go. Just stop yelling out stuff. Just stop yelling out stuff. I want to check out 1 year. So after 1 year, how much is left? I can't plug in a 1 here because that means 1 decade. How do I write 1 year? 0.1, which is the same as what is a fraction? A tenth. So 1/10 of a decade. When I want to try 2, what do I plug in? 2 years. What do I plug in for the decade? What do I plug in? 2/10. So what you're going to do right now is go ahead, find out what's left after 1 year, a tenth of a decade, find out what's left after 2 years, and then go to each multiple choice and plug in 1 and 2 for the years. Okay, plug in 1 and 2 for the years. Go ahead, I'll give you time. And I'll show you a shortcut so we don't have to do this every single time. So find out after 1 year how much is left. After 2 years, how much is left. And then find out which multiple choice would match that after you plug in 1 and 2 for Y. What's up, Jess? So you guys are finding out the values of 1 and 2 years and then finding which multiple choice would match that after you plug in 1 and 2. Make sure you're not, when you go to the multiple choice, make sure you're not plugging in 1/10 and 2/10. You're plugging in 1 and 2 because those are the number of years, right? Is that 152 or 752? I can't read my writing. 752? What are you guys finding out? Choice 3. Again, this is years you're plugging in now. This is years, so you have to plug in 1. You'll get right around that one. And you plug in 2, you should get right around 674. Ready for a quick shortcut? Quick shortcut. Basically, how do I turn this equation into one of these without having to plug in 1, 2, 3, 4 and checking all the multiple choices? Not a big deal. You'll notice the 714s never changed. What changed was the B value. All right, so the 714s never changed. Everyone ready? The D went to a Y, decades went to years. What did we do? 1 over 10. So instead of having a D there, what's years? What's 1 year as far as a decade goes? 1/10. Everyone in your calculator right now, go ahead. 0.75, excuse me. 0.75 raised to the 1/10. Go ahead. And what do you notice? .9716. Okay, so that's all we had to do here was change that decade into years. It's 1 year is 1/10 of a decade. All right, 1 year, 1/10 of a decade. So that's where that 1/10, 0.75 to the 10th, gave me that raised to the Y. All right, questions? I got one more and then you're on your own. And it's everyone's favorite, right down below, probability. Here you go. What are you guys on? 14 on your formulas, not on the formula sheet? We're up to 14. Okay, here you go. If it's independent or not. I know it's been ages, and it wasn't our strong point. If independent, probability of A, anybody, this would be great if somebody remembered. Anybody? The probability of A given B should have been the same as the probability of, guys, you're going a little too far here. Just A by itself. Okay? Shouldn't matter what I give you. They should be equal to each other. Okay? All right, keep that right out in front of you because you guys I showed you at the beginning of class today how to find that probability. All right, so go back to, if you need to flip the page back, go ahead. All right, what are we testing for independence? Probability, what's independent? That they have blue eyes and blonde hair, right? Okay, so let's do it. So if it's independent in this problem here, the probability of blue eyes, what do you think, blue? Given that they have blonde hair, if they're independent, you tell me, what should that be the same as? The probability they have? The probability they have? Blue eyes, yep. So you and I test it right now if this is true or not. Is this a true statement? Well, let's figure out what's the probability they have blue eyes. Read through the problem again. That's a pretty easy one. Read through the problem. Probability they have blue eyes, 0.25. All right. Look back on the formula sheet there. How do I find this probability of blue given blonde? What's got to go on top? And. Blonde and blue. It's already given to you. It's already given to you. Blonde and blue. What do you got for me? 0.125 over what goes in the denominator. Look at your darn sheet. I gave it to you today. What should go on the bottom? The and on top. What goes on the bottom? What's given, in this case, blonde. What's the probability of blonde? 0.5? Go ahead. You let me know if they're independent or not. 0.125 divided by 0.5. What's that end up being? 0.25? Yes, everyone getting 0.25 out? So that tells me what about these two events? They're independent. But we got to talk about that number 3 there. Anybody remember mutually exclusive? Jess, would you remember anything about it?
It means that if one happens, the other will happen.
At the same time.
Yes.
All right? Two events cannot happen at the same time.
Red hair and blonde. Well, I guess.
Meaning, here you go, simpler one than the one we're doing now. I have a 1 roll of the die. Can I get a 2 and a 6 at the same time? That means they're mutually exclusive. Can you have a blue-eyed, blonde-haired kid at the same time? Yes. So are these mutually exclusive? No, they are not. Meaning they're just independent. Okay? It can happen at the same time that you have blue eyes and blonde hair. That can happen. Okay, so they're not mutually exclusive. Whew, we all right. Okay, so the remaining amount of time, tonight on your own, tomorrow before you get into class, I'm calling these OYO, on your own. I'm going over all of them tomorrow. So there's what, 6 problems? So 6 different people are going to show me how they did it. Hold on. I'm not going to leave you swimming. Back of this, answers to the multiple choice. Up on Aspen are answers and work to everything. But I'm just telling you, be prepared to explain yourself tomorrow for numbers 1 through 4, 25, and 26. Okay, be prepared to, yes. What's that? Still in the June. Still in the June. Okay, so please be prepared tomorrow to tell me how you did each problem. You can get going right now with people in your group. I'll come around to help you out. 1 through 4, 25, and 26. Okay, make sure you're checking your answers. 6 people tomorrow are going to tell me how they did it real quick.